I guess you should move somewhere cheaper.
Cheap exists in this economy?
It does. Lower rent means affordable life, to be honest.
Don't you think that's a very confident equation for someone who didn't even use Excel? So your theory is cheap rent equals affordability,
Yeah,
and your source is?
from life.
Yeah, right. Let's test it then. To test this properly, I collected rental data for 20 suburbs across Sydney using real listings from Domain.
But how do you know it actually represents Sydney? Like, it's just only 20 suburbs.
No, I'm not trying to represent every suburb. I'm just trying to capture the range like low, medium, high. I started by organizing everything in Excel. In column A, I listed the 20 suburbs. In column B, I entered the weekly rent for each one. And in column C, I added the weekly student income. And I used it from the youth allowance in Australia, which pays $677.20 per fortnight. So weekly, we are working with $338.60. I filled this figure down across all 20 suburbs by dragging it down. So every single suburb is compared against the same income baseline. That's how we see and keep the comparison fair. Rent alone doesn't tell you anything. What matters is proportion of income. To calculate this, I divided the weekly rent by weekly income. That's column B divided by column C. I applied the formula once and dragged it down for all 20 suburbs. Then I converted it to a percentage. This gives us the rent burden for each suburb, the percentage of income that goes purely to rent before you have paid for food, transport, phone, or anything else. To classify each suburb, I used an if function. This is one of the most useful decision tools in Excel. The logic works like this. If the rent percentage is 30% or less, the suburb is classified as affordable. If it's above 30%, it's classified as not affordable. The 30% rule is a commonly used benchmark in house research. The idea is that spending more than 30% of your income on housing puts you under financial stress. It doesn't leave enough room for everything else you need to live. So the if function here is doing something quite powerful. It's turning a number into a decision. It's not just telling us how much rent costs, it's telling us whether that cost is sustainable. And when I look at the results across all 20 suburbs on youth allowance alone, every single one of them is classified as not affordable. Not one or two, all of them. Now, most students don't survive on allowance, be it by government or their parents alone. So let's make this more realistic. I introduced a second income scenario that is $700 per week, which represents a student working part time on top of their allowance. I repeated exactly the same calculation using this higher income figure, rent divided by $700, and applied the same 30% if function to classify each suburb again. This gives us two scenarios side by side. Now we can compare and see how much of a difference having a part time job makes, which we can see that even with a higher income, the result is still overwhelmingly not affordable, which tells us something important. The problem isn't just that the students need to work hard, the gap between income and rent is large enough that part time job alone does not close it. To see the bigger picture, I grouped all 20 suburbs into three categories based on weekly rent. Under $600 is cheap, 601 to $800 is mid range, and above $800 is expensive.
You already have all the numbers. Then what does grouping actually change?
It helps us see patterns instead of individual suburbs. To summarize by category, I created a pivot table. I highlighted all the data, went to insert, and selected pivot table. In the pivot table setup, I placed category in the rows field and rent percentage with part-time income in the values field. Then I right-clicked the values and selected summarize values by and chose average because I want the typical rent burden for each category, not the total. From the pivot table, I created a clustered column chart. I highlighted the category column and the average percentage column, went to insert and selected the clustered column option. After the chart appeared, I cleaned it up. I removed the individual suburbs label because we're comparing categories now, not suburbs. I rearranged the order so it reads cheap, mid range, expensive from left to right, which makes the progression logical and easy to follow. Under design, I added a chart title and axis labels so it's immediately clear what each axis represents. And here's what the chart shows. Even in the cheapest suburbs, rent takes up around 78% of income without part time earnings. Mid range suburbs reach approximately 109%, meaning rent costs more than a student's entire weekly income. Expensive suburbs reach about 132%. Every single category is well above the 30% threshold. Not close to it, not slightly above it, more than double, triple, in some cases, more than 5 times the benchmark. That's not just expensive, that's structurally unaffordable across the entire city. To go even further, I created a scatter plot. I selected two columns, weekly rent and the rent percentage with part time income. I went to insert, chose scatter. After the chart appeared, I added a title and axis label using the add chart elements. Then I clicked on one of the data points, right clicked and selected add trendline. In the trendline options, I kept it as linear and I ticked display equation on chart and display r squared value on chart. A scatter plot is useful here because it shows us the relationship between two variables visually. Every dot is one suburb, the x-axis is rent, and the y-axis is the rent burden percentage. And the trend line cuts through the middle to show the overall direction. Now, this is not just a pretty chart, it's actually doing statistical work. Let's start with the trendline equation. It reads y equals 0.0014x. What this is telling us is that for every $1 increase in weekly rent, the percentage of income spent on rent increases slightly. Or to make that more intuitive, for every $100 increase in weekly rent, the burden increases by about 14 percentage points. That's a steep relationship. In regression terms, what we have built here is a simple linear regression model. Weekly rent is our independent variable, the thing we are changing. Rent burden percentage is our dependent variable, the thing that responds. And the equation shows exactly how sensitive affordability is to rent increase. Now look at the r squared value. It's equal to 1. That means 100% of the variation in rent burden can be explained by the level of rent. The closer r squared is to 1, the stronger the relationship. And here it's perfect, which tells us this isn't random. The relationship is consistent and very strong. Now, if we frame this as a hypothesis test, our original idea was that the lower rent equals an affordable life. So the null hypothesis is that the rent is affordable, meaning 30% or less of income. When I applied the if function across all 20 suburbs on youth allowance alone, 0 out of 20 were classified as affordable. Even with part time income, the result is still not affordable across almost all suburbs. The data consistently and repeatedly fails to support the null hypothesis. So we reject the idea that the Sydney rent is affordable for students. And visually, this chart is your evidence. Every point follows the same upward pattern. As the rent increases, affordability gets worse. That's what data backed evidence looks like when all numbers point in the same direction. Now, good data analysis isn't just about showing what the data says, it's also about being honest about what it can't say. So, let's talk about limitations. First, sample size. This dataset covers 20 suburbs. That is a sample, not a census of all of Sydney. I chose these suburbs deliberately to capture the range, but a different selection of 20 might shift the exact percentage slightly. That's what we call sampling uncertainty. Anytime we work with a sample, there's a margin we have to acknowledge. However, and this is important, the pattern we found is so consistent across every category that it's very unlikely a different sample would reverse the conclusion. When the cheapest suburbs are already at about 78%, and that's the best case, a few different suburbs won't bring that below 30%. Second, income is treated as fixed. Every suburb uses the same $338.60. In reality, student income varies. Some receive family support, some work more hours, some receive scholarship. The $700 part time figure is a reasonable estimate, but it's not guaranteed for every student. What this fixed income approach gives us, though, is a controlled baseline. In data analysis, holding one variable constant so you can isolate the effect of another is actually the right approach. We're not just pretending every student earns exactly this. We're saying for a student at this income level, this is what the data shows. And despite these limitations, the pattern is clear enough that the conclusion still holds. It's not one outlier making Sydney look bad. It's every category, every bar, all above 30%. That's the level of consistency across a sample, giving us confidence that this finding reflects something real.
So basically, Sydney being expensive isn't just a rumor, it's actually true.
No, unfortunately, data confirms it.
So the advice we started with, that doesn't actually work.
You mean the cheap rent theory? Yeah, it sounds right until you actually put it to the test. Next time someone has a theory, pull up the data.